Number 11. Now for the fun stuff. Find an equation of the line containing the given pair of points. So we have 2 points, 4, negative 22, and we have 5, negative 29. Okay. So remember, when we're finding an equation, we need to write an equation in y equals mx plus b form. Well, we need to find an m and we need to find a b. And once I have an m and a b, I can write an equation. So the first thing we're going to do is let's find m. And the slope formula is on your formula sheet. But if you don't remember it, it's pretty much subtract your y's on the top and subtract your x's on the bottom. And just be consistent. So if I start off with negative 29 minus negative 22, then I better go 5 minus 4. Okay, I have to be consistent. And watch your signs. That's the number one mistake students make on these types of problems, is signs. I'm subtracting, so negative 29 minus negative 22. So many times students forget to put the negative 22. Well, it's already a minus. Well, okay, it's going to change your answer if you don't include that. So now I have my slope is, so it'd be negative 29 plus 22. So negative 7 over 1, or just plain old negative 7. So m equals negative 7. So there's part of our answer. We're going to need that eventually. Now I need to find the b. Once I have that, I have all my parts that I'm going to need for my equation. So now let's find the b. Well, to find b, you can do 2 different things. You can use either the point slope formula, which is usually what I like to do, or you can use y equals mx plus b. But it's kind of up to you, whichever one you prefer. Both of them are on your formula sheet, so it doesn't matter which one you use. Are you guys partial to one or the other? We do y equals mx plus b all the time, so I don't know if that one is one that you're more familiar with. Or I like the y minus y1 equals m times x minus x1, because when you get to the end, you're done. You don't have to worry about going back and rewriting a problem. So that's the one that I like to use. And again, this is on your formula sheet, so you don't have to memorize it. And what we're going to do is we're going to put in the negative 7 for the m. The y, it's y minus the y coordinate. Now I actually have more information than I need, so I just pick one of the coordinates. It doesn't matter which one. I'll just pick the first one. So y minus the y coordinate, so that'd be minus negative 22, equals negative 7 times x minus the x coordinate. There still needs to be a y and an x in your equation. A lot of times students will try to drop that other coordinate, that 5, negative 29, in for the y and the x, and then everything's numbers, and what do you do, and how do you solve? Well, you can't solve that. It's all numbers. There's nothing to solve for. So remember, you're finding an equation. The equation will have an x and a y in it. So it's y minus the y coordinate equals 7 the slope times x minus the x coordinate. Now all you have to do is simplify. This is y plus 22, because minus a negative. This would be negative 7x plus 28 after you distribute. And then all you have to do is move the 22, and then we'll have our answer. So let's see here, y equals negative 7x plus 6. So let me check the answer. Yes, we are good. So there is our answer. Negative 7x plus 6. 13, we have write an equation of a line described through the point 6, negative 15. and parallel to negative 7x plus 6y equals negative 78. Now, what's true about parallel lines? They have the same slope. So all we need from that equation is the slope. And I will use that slope, and I will use this point, and I will write a brand new equation. So I'm going to convert this into slope-intercept form so I can identify the slope, which means I just have to get the y by itself. So I'm going to have to move my x term, the entire term, and that's going to give me 6y equals 7x minus 78, and then divide by 6. So I have y equals 6x minus 78 over 6. And I'm not going to worry, I know that'll reduce, but it doesn't matter to me because I don't need it. All I need from this equation is the slope. That's all I need. Since we need to write a brand new equation that is parallel to this equation, I am going to use the slope m equals 7/6. And I'm going to use this point, and that's going to give me a brand new equation. A lot of times students do this, and they're like, oh, I'm done. No, you're not. You didn't find a new equation of a new line that's parallel to that line. All you did was take the current line and rewrite it. You didn't find a parallel line to it. So now I'm going to do what I did on the last problem. Y minus y1 equals m times x minus x1. So it's y minus my y coordinate equals m, which is 7/6, times x minus the x coordinate. And then we just number crunch. Now, had this said perpendicular, how would that have changed our problem? Any ideas? Remember, perpendicular lines, they don't have the same slope. Their slopes are negative reciprocals of one another. So if it was a perpendicular line, we wouldn't have used 7/6, we would have used negative 6/7. But it looks like you're going to have a parallel problem on the final, so you don't have to worry about that.
There's another one for you, Jesus.
So let's see here. So y ends up being 7/6x minus 22. Anybody else get that?
Yeah.
Okay, good. So this line is parallel to that line because they have the same slope, but that line goes through that point. Solve using any method. This is a system. We can solve by graphing, solve by substitution, or solve by elimination. Now we're not going to do graphing. So we can do either substitution or elimination. Now this one is set up perfectly for which one?
Y.
Yeah, it's got y equals, so it's set up perfectly for substitution. So since y equals 2x minus 3, then we're going to take that and we're going to plug it into the other equation for y. That's going to give me a brand new equation of 4x plus, so instead of y, I'm going to put 2x minus 3 because that's the same thing as y. And so there's my brand new equation. So my original two equations are up at the top. My brand new equation after I use substitution is 4x plus 2x minus 3 equals negative 15. That equation I can solve. I just have to combine some like terms. And keep on solving. Now keep in mind that the solution to a system is actually an ordered pair. Because if we were to graph these two lines, they would intersect. And what we're looking for is that intersection point. We're looking for the one point that makes both equations true at the same time. So when you get all the way down here to the bottom and you get x equals -2, am I off? No, okay. I'm only halfway there. So we have to find the y that goes with it. So pick one of your equations. Now it's probably going to be easier to pick the top one and replace the x with -2, since that's what we said x is. And this will give us the other half of our answer. So it looks like y equals -7. So the final answer is an ordered pair, -2, -7. If we were to graph these two lines, that's where they would intersect, at -2, -7. So 17, we have x minus 4y equals 4, and we have 2x minus 3y equals 8. Now this one you could do substitution as well, but you would have to solve for a variable first. So you would have to, the easiest one to solve for would be the x in the top equation. If you swing 4y to the other side, then you could use substitution method. Since we've already done one with substitution, I'm going to just, let's review elimination method. Elimination method, what we want to do is add our two equations together in hopes that either the x's eliminate or the y's eliminate. Now, if I add them in their current state, nothing eliminates. So, in order for something to eliminate, like the first, if we wanted to eliminate x's, since the bottom's 2x, the top would need to be -2x. If I wanted to eliminate the y's, I would have to, since one's a 4 and one's a 3, one's positive, and they're both negative, we would have to make one of them positive, and we'd have to multiply both of them by something to get a common number, which would probably be 12 in this case. It's going to be easier to eliminate the x's. So if we multiply everything by -2, we get a brand new equation. It's equivalent, but then our x's would eliminate when we add. So my brand new equation is -2x plus 4y equals -8. I'm going to bring over that bottom one. I don't have to do anything to it. And I get, well, my x's eliminate when I add.
Ms. Jensen?
Yep.
Since you have to times -2.
Okay, so, yeah, let's fix that.
All right.
No, you're fine. No, you're fine. I'm glad you stopped me there. So, yeah, -2x, it'd be positive 8y, yes. It's like I did the first and the last, but not the middle. I don't know how that happened. Okay, so 8y. Are we good now? -8? Yeah.
Yep.
Okay. So let's keep adding. So -2x, 2x gone. 8y, -3y ends up being 5y. Equals, well, that'd be 0. Okay, which is fine. Now, what's y have to be? I mean, you could divide both sides by 5. But y is going to be what? 0. Now, some students, they panic and they think, oh my God, is it no solution? No. -8 and +8, 0. 0 is a number just like anything else. And that's a location on the coordinate plane. So that's fine. So we got y equals 0. Remember, that's half our answer. So let's plug that in to one of our originals. I'll just pick the top one. Replace y with 0 to find out what x is. So it looks like x equals 4. So final answer, 4, 0.